Hello, my name is Dávid Fehér, and my presentation is about the challenges in responding to ransomware incidents in cloud-connected IoT environments. The following slide represents the Google search trends on ransomware-related words and IoT search words. So, as you see in the picture, the main pike is related to WannaCry, which is a really famous ransomware. It was based on these Google trend words. These were the most famous, most known ransomware, and all over the world, the news were full with the informations and news about the specific ransomware attacks. It was targeting several different people, and it was quite. It had a quite high impact in the medical and the healthcare related industry. It was all over the world. People were know about it, and as per my own background and the people around me were quite afraid of this specific ransomware during that time. So yeah, as we see there, that was a quite big spike there. I was looking for other search words, but other ransomware names were not that much famous, and those were not that much searchable because those were overlapping with some other meanings. This WannaCry was quite specific and quite well known, and even nowadays, most of the people still know what does WannaCry mean when they hear it. And as you see in the picture, the rising around the ransomware search words is, and if you see the trend line there, that's rising, and year by year it's increasing, and in the same time the IoT trend line is increasing as well. So the IoT is getting more and more well known and more built into our daily life, and it gets even more popular. Even more systems are connected via IoT or to IoT systems and so on, and it will make this as a better target for the ransomware threat vectors, which means we will need to prepare for this type of attacks, and we will have to expect more from this type of attacks. This slide represents a picture about, or a diagram about the standalone MQTT broker architecture on Google Cloud, which is a quite popular ways to handle the communication between the IoT edge devices and different cloud services there. It provides a quite secure and quite good environment and background to handle all this. But the fact it exists means, yeah, more and more devices are there, and all the different providers and companies are trying to make further developments. They are trying to make these systems more connected, more interconnected, and sometimes the security is not the most important for them, which is not the case with the MQTT in case of Google Cloud, but still it's a problem. And as we see here, several different, so it's a day-to-day everyday activity nowadays to have IoT devices connected to different cloud services there, and it means it have its own connection to other systems. It can, well, contain, or it can be published because of lack of knowledge, because of user mistakes there. It can create issue there due to actual vulnerabilities or different new findings which are not yet patched or not yet reacted, or there are several different type of vulnerabilities which are usually populated, and it takes time for the production system to get updated for those and get those vulnerabilities patched there. Making systems more secure is a best practice nowadays, and as I see, most of the big companies are doing their best to make all of the systems more secure, but there is no such thing as free security. I mean, the companies are trying to bake the security into their systems, but there is always a cost for for these extra security layers there. And there are challenges to get all these IoT systems as cost efficient as possible, but at the same time managing the cybersecurity risk with it. And it's a challenge to make the systems more secure but keep them well usable, because usually the security controls are well limiting the ways of using of those devices and systems and environments, and making those systems more secure by this. But at the same time it just introduces extra latency, extra cost, extra work there, extra limitations, extra separations there, which are as a which are acting like as a real cost there. Robust incident response plans and procedures are really important, because we have all these really complex interconnected systems there, and having the proper team to monitor and analyze those enormous amount of data which is fetched to these systems is impossible. So we have to use these type of automations, we have to use the CM systems and SOAR systems, just to make sure all the incidents and alerts are addressed as soon as possible, and the response happens on time, based on the as good as real information, as good information as possible. And it's a industry best practice to use the NIST incident response and related guidelines and other NIST guidelines to make the environments more secure, introduce cross-functional team work-related procedures there, and establish the proper communication channels, and have all these proper strategic recovery plannings there. And here right now I'm presenting the NIST incident response lifecycle, which contains the preparation, the detection and analysis, containment, eradication and recovery report, and the post-incident activity. As you see here, all the arrows and all the steps are having its own effect in the next and in the having the effect on the next and the previous steps there, which means these are quite ever-evolving procedures there, and it means there are several different lesson learned. The systems are changing, developing, and there are new vulnerabilities there. There are new ways of handling the new type of attacks there, and so on. Which means this is there have to be a proper procedure there, and in NIST helps us to get this proper knowledge and proper framework for this. But to meet with all those framework related requirements there and framework based steps there, we have to have proper preparedness there. For example, continuous assessments and preparation to handle the evolving threat landscape and ensure rapid and automated incident response. Because without automation, nowadays it's even the attackers are using AI solutions and using automated solutions to, as soon as they breach our system, make as much damage there as possible. So we have to step as soon as possible in an as reliable way as possible, and for it we have to minimize and decrease the human work there, and create the proper incident response in an automated fashion. And to meet all this, we have to properly assess our systems, how they are working, what are the security and risks there, and those have to be assessed. And just to make sure if we meet with all the business needs, we define the proper KPIs and availability information for the system, and based on those needs for those availability, we design our systems and we prepare for those incidents based on those. We have to ensure reliable security measures are in place in the IoT connected systems to quickly address the ransomware disruption and quickly identify the impacted system, just to make sure we are decreasing the widespreadness, and we are decreasing the chance of the widespread of these ransomware attacks, because these can create a real pain for us. And for the most critical systems, proper backup solutions have to be in place, and proper automated backups in a way where we can continue our business critical business there without business disruption. And in the meantime, still we can keep the evidences for investigation, because there could be legal requirements and insurance related requirements as well for this. So to meet with these in the cloud environment, the infrastructure as a code solutions are quite good, because those provides us the proper tool set to make sure we can respond in a way which is leaving the actual infected environment behind, and we can produce a new clean environment there in a separated way, and we can segregate the actual environment what was infected, and that can meet with our requirements about keeping the evidences for the investigation and for the other insurance related requirements. But it's always important to consult with the proper lawyers and insurance representatives, just to make sure these response systems are in line with their expectation. This diagram represents the incident response and highlight the influence between each phases there. The preparation is always based on the assessments, but it still relies on the previous lessons learned and relies on the history of the company, as we see represented by that arrow which pointed to the preparation phase. The preparation phase contains several different steps like incident response and policy team development, security management activities, and automations of toy work and critical response activities, training and awareness programs. The second step highlighted here is the logging, which is the heart of the incident response, because without knowing what's going on in the environment, we cannot properly react to those alerts, to those attacks there. So proper log source discovery, log generation, log collection, log reviews, and log noise and cost reduction is really important there. And the next phase covers the alerting, which contains the detection rule definition, detection rule configuration, and detection rule tuning. And the logging and alerting are going there hand in hand, because if there is any significant change in the logging, the alerting have to reflect to those. The next phase is on the analysis, which is building on top of the preparations, the logging and the alerts. And again, based on the findings what we see there in the analysis, it will have effect back to through the rule tuning to the alerts, and through the alerts back to the logging even. And in the analysis phase, the validation, escalation, threat hunting happened there, and based on their real incident finding or potential incident finding, they are a trigger for the response activities, for containment, for education, and for it can request again further analysis there, which can end up as rule tuning and affecting and having effect back to the previous steps there. And the sixth step is the recovery, which is after the incident happened, or as soon as the incident is analyzed and checked, and the data recovery can happen at the same time like the response in case of really business critical systems there, but their proper preparation is needed, and proper risk analysis, security assessment is required there. And once everything fixed and the incident was properly closed there, after that one, still as part of the incident response, the last step is the post-incident activity, which contains the incident analysis and checking where they can improve the systems there, and take the lessons learned and process development based on those, and development of the previous steps, for example, having effect on the preparations, having effect on the recovery steps and on the response or analysis steps as well. Due to the rising value of these systems and the rising value of the system which are relying and building on top of these systems, and as the threat surfaces are opening and getting more wider and wider, and the new vulnerabilities of these systems are popping up week by week, all these makes these systems great and easily reachable target or reachable target of the attackers, and it makes it an attractive target for the attackers. The number of attacks are rising, and the number of ransomware attacks are rising as well. And we have more global and more interconnected systems than ever before. The question is not if the company will be a victim of the ransomware attack, but when. Thank you very much for your attention.